Hi everybody, this is Math 024, Module 1, Video 1 on rules of exponents, and then in the future videos we'll continue with rules and also look at applications, and this is for Hartford Community College. An exponential expression is any expression containing one or more exponents. For instance, in the following expression here, 3 is the base and 5 is the exponent. The whole thing together, like 3 to the 5th power, the whole thing is called a power. And again, the power is made up of a base. And I always remember the base is the big number because B for big goes with base. And then the 5 is the exponent. And what I think about when I think about exponents is, that little number tells the big number how many times to be in a math problem. So if it's 3 to the 5th power, that means we're going to do 3 times 3 times 3 times 3 times 3 and multiply it all together. Sometimes I think of like little dogs, like, Chihuahuas, for instance, are, they're tiny dogs, but they always think that they're like big and bad and they tend to bark and they go up to anything. So think of it like that. This is the little dog, but it's bossy. So it tells the big number how many times to be in a multiplication problem. So for instance, here, because we have parentheses around the -4, it's -4 to the 3rd power. So it would be -4 times -4 times -4. Not -4 times 3. So it wouldn't be -12. It would be -4 times -4 times -4. Next, what we're going to do is we're going to look at some rules for working with exponents. So how to simplify problems that may have powers in them and what to do with those exponents. The first rule that we are going to look at is the product rule. And product, remember, is the answer to a multiplication problem. So here the rule says if you have a to the mth power and a to the nth power, if you are multiplying powers with the same base, so here the base has to be the same, so a and a, those are our bases, remember the big part, then to simplify the expression, you're going to add those exponents. So down here, if you look at a, we have x to the 9th times x to the 5th times x to the 7th power. If you notice, all of our bases are x, so they're all the same. So when I go to simplify this problem and using the product rule, I'm going to keep my base of x. And then what I'm going to do is, because it's all multiplication, I am going to add the exponents. So that will give me, if I do 9 plus 5, it's 14. 14 plus 7 will give me x to the 21st power. Now, let me show you a good reason why this works. So with exponents, and I'm going to make it a little bit smaller here. I'm going to say x to the 3rd power times x to the 4th power. All right, now x to the 3rd power, that is written in power form, but if I wrote it in expanded form, remember, like we talked about on the other side, that little number 3 tells the x how many times to be in a multiplication problem. So there's my 3 x's. Then I keep my times sign, and I have x to the 4th power, which is going to be x times x times x times x. So if you look at that and you count how many x's I have here now, there are 7 of them. So it would be x to the 7th power for that one. And again, that's the same as adding the 3 and the 4 to get the 7. I just put it out in expanded form to kind of show you why we add those exponents. All right, so now for the next one, for B. This one is a little bit different in that we still have some powers that we need to simplify, but we also have different terms here. Like I have 6 times n to the 4th power. So if I were to rewrite that problem, I would write it as, or one way to look at it would be 6 times n to the 4th times 10 times n to the 8th. And really what I want to do here, when I write it out and I put a multiplication symbol between everything, is to kind of show you the differences between the coefficient of the term, like the 6 is the coefficient or the number part of the term, and the power there. So here what we're going to do is really, when we go to simplify this, put all your plain old numbers together. So 6 times 10 And then let's put the powers together. All right, now notice 6 times 10, that is 60, so we can keep that. N, we have n to the 4th and n to the 8th. The base right there is the same. So because it's the same, I can use the product rule. And to simplify it, I'll write n once, and my exponent will be the sum of the two exponents. So 4 plus 8 is 12. And then we can't do anything else with that because we don't know what n is. So 60 n to the 12th power is my final answer there. All right, let's take a look at C. So again, I have negative 2x squared, which is the same as negative 2, again, times that x squared, times negative 4 times x to the 3rd. And again, I'm just separating it so you can see it. Once you get good at this, you don't have to write it out. You can do it in your head, just the separating. So again, now what I'm going to do is I want to put all the numbers together and then all of the powers with the same bases. So I have negative 2 times negative 4 times 5. So those are all my numbers. And then it is, x squared, x to the 3rd power, and x to the 4th power. So when I multiply my regular old numbers here, negative 2 times negative 4 will give me 8, positive 8, because two negatives make a positive. And then positive 8 times 5 will give me 40. So I have 40. And now I have to look at my powers. They all have a base of x. So that means that I can just write my x there and add my exponents. So it will be 2 plus 3 is 5. 5 plus 4 will give me 9. So my final answer is going to be 40 x to the 9th power. All right, so here, again, we're going to keep looking at some problems where we have powers, and we're going to simplify them using the product rule. Now, for D, one thing to note here is we have two different bases. We have x, and then we also have y. So just like I separated before, I'm going to separate up my different bases. So I have, x squared times, oops, let me erase that real quick, times x to the 10th power. And then I have y cubed, or y to the 3rd power, times y to the 11th power. So now, again, remember, in order to do the product rule, you can add your exponents if your bases are the same. So where my bases are x's, those bases are the same, I can add those exponents. So x squared times x to the 10th will give me x to the 12th. And then we'll keep our y because it's going to be times y. And in this case, we can add these exponents because the y's are the same. So 3 plus 11 will give me 14. So this is all that I can do with this problem. And my final answer here is going to be x to the 12th power, y to the 14th power. So now for E, we've got some numbers in there, and then we've got some powers with different bases. So again, organize it all together, separate what you can. So let's put our numbers together. We have negative 2 times negative 5. And then, let's see, we have a squared times a to the 7th, and then times b to the 4th, and b. So when I go to simplify this, negative 2 times negative 5 is going to give me a positive 10, because two negatives make a positive. Now when I look at my a's, again, because they have the same base, I can add those exponents because I am multiplying them together. And 2 plus 7 will give me 9. So I have 10, a to the 9th. And now for b's, I have b to the 4th times b. And every variable and every number really has an exponent. If you don't see it, I call it the invisible 1 there because you have 1b there. So if it helps you, write it in. And we have b to the 4th times b to the 1st, which is going to give us b to the 5th power. So my final answer there is going to be 10, a to the 9th, b to the 5th power. All right, let's take a look at our last one here. We have F. And again, separate it all out. So I'm going to start off with my numbers. So I'm going to have 4 times 10 times 3. And then look at your s's. So it's going to be times s to the 7th times s to the 2nd. And then we'll worry about my t's. So times t to the 9th, and t to the 3rd. All right, my numbers, when I multiply them, 4 times 10 is 40. 40 times 3 is 120. Now, if we look at the s's, again, I have s with no exponent. So remember, there's one s there, so it's s to the first power. If it helps you, write it in. And then when I add those exponents for only the s's, I have 1 plus 7, it's 8. 8 plus 2 will give me s to the 10th power. And then finally, when I look at my t's, again, I have t to the first power. So it's going to be 1 plus 9 is 10. 10 plus 3 will give me 13. So my final answer is 120 s to the 10th power t to the 13th. So the important thing to remember with the product rule is you add your exponents, but you can only add exponents with like bases. So make sure you separate those bases and look at all for like all the s's, all the x's, all the y's, all the t's, whatever variable it is. And then also any numbers out there, multiply those together. So now we are going to look at the quotient rule. And this rule is applied when we are dividing powers with like bases. So the product rule, we multiplied powers with like bases, but now we are dividing powers with like bases. So with the quotient rule, think quotient, that's the answer to a division problem. So here, when we divide, instead of adding exponents, we are going to subtract them. And when we do that, that will combine our bases into one single one. So like here, for x to the 9th divided by x to the 3rd power, I am going to do, to get my answer, x to the 9 minus 3 power, or it's going to equal x to the 6th power. Now, if I show you how that works, I'm going to do something a little bit smaller. Let's say I have x to the 5th power divided by x to the 2nd. So if I were to write this out on the top, if I write it out in expanded form, I have 5 x's there and then 2 on the bottom. Now remember, with fractions, if you have the exact same thing on the top and the bottom, that equals a 1. So that, we call it, say it cancels out, but it equals a 1. So I have one pair there that will cancel out, one pair there. And then when you look, what's left is the 3. So that's how, if I subtracted 5 minus 2, I would get x to the 3rd, or if I wrote it out, I get x to the 3rd. So that's just kind of why it works, how we do it. For B, again, your bases have to be the same. Both of my bases are 3. 17 minus 14 would give me 3 to the 3rd power. And then for C, both bases are negative 2, so I'm going to keep the negative 2, and the fraction bar is removed once we subtract. So 25 minus 20 is going to give me 5. So I have negative 2 to the 5th power, and you do want to put parentheses around that negative 2, so we know the 5 goes to the whole problem, not just the 2. So now we're going to continue with the quotient rule, and we're going to look at some, again, where they're going to get a little bit more complicated. We're going to have some coefficients to deal with, and then some different bases. So if we look at D, what I like to do is kind of draw a line. So the first part, if you think about it, is we have just a regular old fraction here. We have negative 32 over 28, and then we have our powers, a to the 12th, a to the 7th, because again, remember that negative 32 is held on with multiplication, but when we're simplifying here, we're going to use it to simplify just like our regular old fraction. So the first thing we're going to do is simplify the negative 32 over 28. And that is going to simplify, let's see, we can divide them both by 4. So we're going to divide them both by 4. And that is going to give us negative 8 sevenths. Okay, so we simplified the fraction. Now we have to worry about the variables, the powers. We have a to the 12th divided by a to the 7th. And because the bases are the same here, we subtract those exponents. So it's going to be a to the 7th. Or excuse me, 12 minus 7 is 5. So it's going to be a to the 5th. Now, there's two ways you can write your answer. You can put it on the top of the fraction, or you could write it -8/7 times, and then put it right next to that fraction bar, a to the 5th power. So either way, that will work, and that will be your final answer for that problem. Now, with E, we have powers. We have two different powers. We have the P and the Q for our bases. So when I look at my P's, if I have P to the 10th divided by P to the 7th, remember, bases are the same. We're dividing those powers, so we subtract the exponents. So my answer is going to become P to the 3rd power. And then Q to the 7th divided by Q to the 1st. Again, and remember, if there's no exponent, you just put a 1 there. 7 minus 1 is going to give us 6, so it will be Q to the 6th power. And because these were both powers that we could subtract, we get rid of that fraction bar. Or you can think of it, it's like it's really, and we don't need this right now, but like it's over 1. But we don't necessarily put that 1 underneath unless we need to do some more work. So we're just going to write our answer P to the 3rd times Q to the 6th power. Now for F, again, divide it up into parts. So we have the 10/50ths, which I can simplify. Then we have our powers with X for the base, Y with the base, and then Z with the base. So 10/50ths, if I divide them both by 10, becomes 1/5. So when I simplify that, and then x to the 16th divided by x to the 7th. Remember, we're going to subtract 16 minus 7. So we're going to end up with x to the 9th power. Then we have our y's. 13 minus 6 is going to give me y to the 7th power. And then z is 10 minus 5 is 5. So again, you can write it like this, right next to the 1/5. Or another way you may see it written is the 1/5 and then x to the 9th, y to the 7th, z to the 5th. Or because that's a 1 right there, we don't really need it. So the best way to write it, if you write it as a fraction, is going to be x to the 9th, y to the 7th, z to the 5th, all over 5. So again, 3 different ways to write it. All of them are acceptable, and all of them are correct. So the next rule that we are going to look at is the power rule. And this rule is where you're going to see, we are going to have a power raised to a power. So it's almost like, I always think of it, I know I need to use this rule when I have 1 power and 2 exponents. So 1 base and 2 exponents. And when you see it like this, when the exponents are right next to each other, then you are going to multiply those exponents. So here for this one, they don't want you to evaluate expressions with numerical bases, meaning they don't want you to like multiply out like here with the 2. They don't want you to do on your calculator 2 to the 9th power. They want the answer written as a power, so a base and an exponent. So here again, we have 1 base, x, and 2 exponents. So it's really x to the 9th raised to the 3rd power, which is really what they're saying is it's x to the 9th times x to the 9th times x to the 9th. Because remember, that 3 tells the base how many times to be in the problem. So this makes it the product rule. We can add those exponents, or 9 times 3 is going to give us 27. So we just multiply those. But this is really why we multiply them, because this is the problem if we wrote it out in an expanded form, what it would look like. So here we have 2 as our base, 2 to the 9th raised to the 10th power. So again, multiply those 2 bases, and it's going to give us, or those 2 exponents, excuse me, 9 times 10 will give us 90, 2 to the 90th power. And then here we're going to do 10 times 20, so we're going to get p to the 200th power. And again, with this one, the difference between the product rule and the power rule is with that power rule, you just have one base and two exponents. So when you see that one base and two exponents, multiply those exponents. Okay, so here we are going to look at two more rules, and they're very similar, so we put them together. It's the product of a power and the power of a quotient rule. And really kind of what I think of this is the distributive property with exponents. So, if I have a times b raised to the mth power, so that a and b are in the parentheses, they're both raised to the m power. Another way that I can write it is a to the mth power times b to the mth power. And again, those bases are different, so you're just distributing that exponent to it. Same thing with division. If we have a division problem raised to an exponent like m, then we put that m with every term or factor on the inside. So a to the mth divided by b to the mth. And the only thing with the power of a quotient rule is that b can never be 0 because we can't have 0 in our denominator. So here with this problem, they want us to simplify each of the following using the power of a product or the power of a quotient rule. So again, kind of think of it as like the distributive property. We have 3x cubed on the inside. And I want you to think about each factor on the inside, each thing that we're multiplying together. Because remember that 3x cubed, it's really the same as having 3 times x cubed. And all of that is raised to the 4th power. And I always like to write it out like that to show you, because you don't always you just think of 3x cubed as one problem. But it's really two factors or two things we're multiplying together. It's 3 times that x cubed. So using the power of a product rule, we're going to distribute that 4 to each factor. So we're going to distribute it to the 3. And here, it's just 3 to the 1st power, so we're going to make it 3 to the 4th power. And then here, remember, x, we have a 3 and a 4, one base, two exponents. So this is where we use our power rule and we multiply. So that's going to become x to the 12th power. So now, sometimes like on my math lab or on quizzes and stuff, they will ask you to multiply out that 3 to the 4th power. If they did, again, 3 times 3 times 3 times 3, would give us 3 to the 4th power is 81. So we could multiply this one out because we know what the power is, but then we have to leave the x to the 12th. And we can't do anything else with it because we can't add those two or multiply them. We don't know what x is. But again, this answer right here for what we're doing would be okay unless they said to multiply out those powers that you can. All right, so again, with b, we have a 5 on the outside, and we want to distribute it to each factor on the inside. And in this case, we have 3. So it's going to end up being 2 to the 5th power. And then we have a to the 3rd power, but we're raising it to the 5th. So again, multiply those exponents. So 3 times 5 is going to give me a to the 15th power. And then 7 times 5 will give me b to the 35th. Okay, because when we're doing the product of a power rule, then we have to apply the power rule. So again, so like distributive property, and then we're applying another rule that we already know. Again, the 2 to the 5th power, if you wanted to multiply it out, it would be 2 times 2 times 2 times 2 times 2, which is going to give us 32 a to the 15th, b to the 35th, if they ask us to do that. Otherwise, leave it 2 to the 5th power. All right, for C, we are going to end up with, again, distribute that 2 to each factor on the inside. So the -7, the p to the 4th, and the q to the 9th. So I'm going to end up with, and here we do want to have parentheses because we want that whole -7 raised to the 2nd power. So -7 to the 2nd power. P to the, again, 4 times 2 is going to be 8 because you want to multiply. And then q, 9 times 2 will give us q to the 18th power. And again, if they ask you to multiply it out, -7 squared is -7 times -7, or 49 p to the 8th q to the 18th power. And that is it for that one. Okay, so now we're going to do one more with the power of a product rule, and then we'll do the power of a quotient rule with set division. So for the first one, again, we have a 3 on the outside. We're going to distribute it to each factor on the inside. So we're going to have -4, and we do want to put that in parentheses to the third power. Now, again, c, it's c to the 9th raised to the third power. So 9 times 3 is going to give me c to the 27th power. And then d to the 11th, 11 times 3 will give me d to the 33rd power. And again, we can leave it like this, or if they asked us to multiply out -4 to the third power, it would be -4 times -4 times -4, which is going to give me -64 c to the 27th d to the 33rd power. And that will be our final answer. Now for E, because we have a fraction here, we do have to distribute this 3 to everything in the numerator and in the denominator. So it gets a little tricky here. So the first thing we're going to do is put it -3 in parentheses to the third power. Because that's a 1, so we just put the 3 there. And then x to the 4th to the third power. Those two powers, or exponents, we're going to multiply. So it's going to become x to the 12th power. Keep the fraction bar. Now it's going to be 4 to the third power. And then y, 5 times 3 would be 15. Okay, so really what you want to do here is you want to see, can we do any simplifying? And like here, -3 to the third power, we do want to multiply that out, get some numbers there. -3 times -3 times -3 is going to end up being -27 x to the 12th over 4 to the third power is 4 times 4 times 4, which is 64. And we have y to the 15th power. Now, if I look at that, 27 and 64, I can't do any simplifying with that fraction. And my x to the 12th, y to the 15th, I have different bases, so I can't subtract the exponents there. So this problem right now is done. We can't do any more. Let's take a look at F, our last one. And again, we're going to distribute the 4 to each factor, the things we're multiplying together, on the inside. So we're going to distribute it to the a to the 3rd, b, c to the 5th, and then also to that -2. So a to the 3rd times 4 is going to make it a to the 12th, b to the 4th, because again that's a 1, so 1 times 4 is 4, and then c, 5 times 4 is going to make it 20, and on the bottom we'll have -2 to the 4th power. And again, put those parentheses around. We can multiply out -2 to the 4th power and turn it into, it would be -2 times -2 times -2 times -2. So it becomes 16. A to the 12th, B to the 4th, C to the 20th. And again, we don't have any bases that are alike, so we can't do any combining. I can't do any simplifying with the 16 because there aren't any other numbers to worry about. So that problem, this is all done. And that will be it for the first video. In the second video, when you watch it, we will look at the 0 power rule, negative exponents, and then we'll do some practice putting all the rules together.